Okay, we're about ready to take this Philco out of its case, and I thought I'd go ahead and just video right from the get-go here. So we're going to remove the knobs, and I'm going to get a container. Sorry for the reach here. Get a container to put the components in so they don't go all over the place. This one's a little tight. Right there. There's usually one. It likes to be difficult. There we go. Okay. I did notice looking at it that there is a little crack here. I don't know if that piece, I guess it has been broken off and glued back on, but that's the only thing I've seen. And there's a small little nick up here in the right top that you can't see in the camera, but it's very small. It's not noticeable. Okay, so we're going to take it out of the case. Let me see this way to lean this. Right, maybe I'll just do it this way. And take, it's got all 4 screws. And get a socket. I don't know how to screw. Again, sorry for my reach, but and I think I'm going to gently lay it on its face to do this so I can balance the unit while I get the bottom screws out. Okay. Now it will come out. I've got to watch the speaker wire. This one does not plug in. Okay. Oops, sorry about that. There we go. Alright, so now we have it that far out of the case. And the bushings are still in there, the 2 in the front of the cabinet. What I'm going to try to leave this in the case for now. I'll just go ahead and take that out of there. That'll help protect the speaker. I think I got enough slack here. Oh, those wires are in bad shape there. So we'll have to be gentle and replace those wires at some point. So that one come off. Set this on here. Get that last cushion off. Then there's a screw going to be very precarious position there. But that's factory, I guess. It goes right between those two wires there. Okay. I have to move it around a lot easier. So there's two advantages of using this cushion material, well, a couple actually. One, it protects my mat, because a heavy chassis would scratch that up some. But that's not what I'm really concerned with. I'm concerned with keeping everything safe. These protect the devices as I'm turning them around and all. They got some padding. And the desk is padded as well. My bench is padded with carpet underneath my pad. And but the other thing is, it makes it very easy to turn a heavy device around. So, and that's a big plus when you're working on something. Okay, there's the antenna wire, AC wire, which is really interesting setup there. Let's just go ahead and get that off. Obviously going to need a new line cord. Okay. I apologize for the sound in the background there. That's my heater. I'm one of those people who's always cold. I do not know why I live in Northeast Georgia mountains, and I do not like the cold. Obviously, with this outrageous accent, I'm not from the Northeast Georgia mountains. I'm from the Northeast United States, where it gets a lot colder, and I'm still too cold. Anyway, okay, so here we have the unit. Let's go ahead and look at it this way. You can get a good idea of what's going on here. We have a metal can tube here. It's a tungsten sole. We have a glass tube in the case here. And I'll get my light back where you can see again. I moved it to move the case out of the way. Cabinet rather. And okay, this is the tuning condenser here, and it needs to be cleaned. Obviously, it's got a lot of debris. We'll clean it out. This is the power transformer. Some more spider eggs in there that are from years gone by. Inhabitants that like AM music, they probably were living in here listening to the outcome of World War II. Or maybe Abbott and Costello, maybe they enjoyed listening to Abbott and Costello on the radio, I don't know. But they enjoyed this radio because there's a few of them I got out of there. Okay. So anyway, there's the radio, and there's the chassis number, 5113. And the dial has got quite a bit of wear on one side, so apparently it was left in about that position there for many years, and the sun did this, it bleached it. So I'll clean it up a little, see if we can get it where we can read it. It's mostly just dust, but it got bleach there as well. And I'll clean it up, and if it's easy to read, then it's up to the owner if they want me to replace it, because there is a company that makes aftermarket dial indicators. Now you notice it's orange in color. A new one would not be orange, it'd be clear or translucent. A lot of this orange is age. They just gotten oranged with age. And I'm not sure, I might be able to find one that is got some tint to it to make it look like this. But, This one could be cleaned up. Okay, we got more critters living in the dial light assembly here. Let's take that off. Check that bulb. It probably needs to be changed anyway, even if it's good, it's old. It's time to change it. Okay, we got it. Get a little cleaning cloth here going so I can do some cleaning while we go. I will clean the entire chassis and all the components, but I just wanted to check this tube. Yeah, it needs to be replaced, which I kind of figured it's old. You see it's got that black spot on the top. That's a usage does that. It's about to burn out if it's not already. I don't know if you'll be able to see. Move some tools out of the way. Okay. Down so they untwist. Okay, let's bring them back up. And now we got some leads here we can use. And we'll check continuity. Can you see that back there? Probably. I know it's quite a ways back there. Okay. That would be a good sound. So we'll check this tube, light bulb. Okay, so it's good, but it's on its last legs. So it'll be good. I'm just going to go ahead and change it at 6 to 8 volts. 25 amps, it must be 2.5 amps, or 0.25 amps, yeah, quarter amp, it's standard bulb. Okay, let me get some of this off here. Piece of the line cord that's deteriorated. Alright, so we'll stick that back on there and we'll get a bulb in there before long. And fix up that wire a little bit, it's kind of rinky-dink. Okay. So, what we got to do, we got a couple of filter capacitors, this can here, and we got these two cans here, which, these are 8, they look like 8 microfarad, and 475 volts, I think. I'm reading it right. And this one's a little easier to see. 8 microfarad, 475 volts. And there's actually 2 in this can alone. And there's 2 in this can, and there's probably 2 in that can. And then 16. This is a 16 microfarad. I need to know the voltage rating on it too. You don't put that on the schematic. But if those are 475, I could just put a 475 in here. It's probably a 250, but it doesn't matter. You can go up in voltage, you just don't really want to go down. I could put these are 475s, but they'll never see 475. I could put 450 and that would be okay. But I ordered some, I got some capacitors coming in, and I know one of the things I did order is 8s, and I was able to get 500 volt 8s on my last order instead of 450s. Higher voltages are hard to get on electrolytic capacitors sometimes. Okay, let's take this guy off. I know where he goes. I just don't want him getting cut. Okay. Now, the other thing we can learn from the top, a couple things. We know we got a 5-tube radio. And we have the 2 IF cans here. And so most likely this is the oscillator mixer, the detector, Take that back. This is probably the oscillator. This would be the first IF, second IF, and the audio detector. And output tube here, which would be a 6F6. And this is the rectifier that is mounted to the transformer, which is something that Philco did on a lot of these older radios, which was really neat for two reasons. One, you have high voltage coming out of the transformer going to the pins of this tube. Rather than having those high voltage AC lines running by other lines that can induce a signal or interference, the wires are directly from the transformer to the tube, and then from the tube out the bottom, DC. And so you don't have that high voltage AC going into the chassis. Really nice way of doing it. Although, of course, it makes it a little bit more expensive. If the socket is bad, you know, it's not as easy as a socket on a chassis to deal with. However, that usually never happens. And we will clean out the pins of this socket. It's basically just a rectifier. It doesn't have a lot of elements in the tube. It just converts AC to DC. Okay, so let's look at the bottom. And here we have the actual not hit anything, just move over there. Okay, now I can move this way more. Okay, and here we have the bottom of the radio, and we have a few more visitors living in here. We have the remains of the mama and the papa that were living in there and listening to the radio morning hour. There's another little guy. I'm not afraid to touch them. There's nothing left to them. They're like 50 years old or 100 years old. That's how old they are. They outlived me. Oh, look at this. So we had a whole family living in here. I'm sure there's more throughout. Okay. Debris and dust and nastiness all over the place. Get all that out of there. A little bit of insulation from somebody's house. And another cobweb. There's some DNA, piece of human hair. Okay. I don't know how the human hair got in there. Just they carried it in there for bedding. Actually, this is pretty clean radio on the bottom for the age. It's not bad. Seen a whole lot worse. Okay, these are the wax capacitors. They got to go. These guys here. And there's not a lot of them, and that's good. 1, 2, 3, 4, 5, 6. 6, there's probably another one around somewhere. 1, 2, 3, yeah. 4, 5, 6. Any on the top? No, I don't see none on the capacitor. Okay, well anyway, they gotta go. That's minor. This is a power resistor, and you can see it got hot, and you can also see why it got hot. This is one of your 8 microfarad capacitor cans that at one time was connected there, and over the years it let go, and so when it let go, it overheated this power resistor. And this is a white, and I'm assuming that's black, and that's a red dot. And you can see it got burnt right through the power resistor. It's probably a 5 watt, maybe a 1 watt dog bone resistor. These are called dog bone resistors because they're shaped like a bone. and so they were called dog bone resistors, as opposed to this Bradley style resistor up there, which is a newer one. So this is a replacement. Well, maybe not. I don't know, these might have been new stock that they had, and this was an original old stock that they had, so they threw it in there. These are sort of like dog bone resistors, but you notice they don't have the strips on the end, the wire wraps on the ends. And Philco did use these a lot too, but they're the same era, okay? And the way you read these when you're working on them, you can remember the acronym for it is BED, which is body, end, dot. So this would be a 9, 0, and red would be 2 zeros, so a 9,000 ohm resistor. This one is red, black, and I can't see the dot, probably on the other side. Could be red, black, red, in which case you would never notice the dot. It'd just be solid red, which lets you know it's a red dot. And then you got a little guy here, which looks like purple, black, and a red stripe, which would be a band. And so that would be a 7, 0, and red band would be 2, so that'd be a 7K. And that's how you read them. The band, brown, black is 0, orange is 4. So you have 1, 0, and 4 more zeros, so that'd be 100K. And that's how you read dog bone resistors. They're not difficult. Okay, the elements that need to be changed in here definitely have to be changed is these electrolytic capacitors. They have a very short shelf life. They go bad fast, and when they go bad, they can take out your transformer, which could be irreplaceable depending on the model. But they could take out your transformer, they could take out tubes, they can cause a lot of problems. They gotta be replaced. This one actually got hot and cold, whatever, and it just worked itself free and broke off, which burnt out this resistor. We gotta hope that it didn't hurt the transformer. So those have to be replaced. The wax capacitors are used for the signal. They allow AC to pass, which audio waves are a single signal, and even high frequency waves, like the IF frequency of the radio, which is in the above human hearing range, is AC. They allow that to pass. What they don't allow to pass is DC, direct current, or like a battery, right? Direct current instead of alternating current. However, wax capacitors, as they get old, like this age, they start to dry up inside, and the electrolytic gets pitted. And when it gets pitted, they start to allow DC to go through from one foil. There's actually 2 foils in there. They're wrapped in like a spiral, like a Danish, or they're wrapped in a spiral around each other, but they don't touch. And they're interwrapped, and they're wrapped into a coil, but they don't touch. They have electrolytic between them, electrolyte rather. It's usually wax and some other compounds between them that keep them separated and isolate the panel, the plates, the foil, so that the 2 aluminum foil sheets don't touch each other. Well, what happens is that stuff in the middle dries out, and as it dries out, holes exist, or the chemical composite of the material changes in such a way that it allows a little bit of electricity, DC, to get through, and high resistance. And as it dries out more and gets older, that resistance drops. And so instead of blocking DC, they become a resistor. They allow some DC to go through. Well, if the DC that they allow to go through goes to a grid of a tube, if it's in the signal line, then you got DC on the grid, which you could burn out a tube, because you're not supposed to have DC on the grid, right? So these guys have to be replaced. They got to go, because if they're not bad, which they are, I can tell you right now they are, they will be bad soon. There's two ways they can go bad, or three actually. One, they can change in value. You notice they all have a value. This one here, for example, is a 0.008 microfarad. Okay, so this guy can change in value as it gets dried out in age. It can either go up or down. Usually they go up in value. They're rated for 20 plus or minus 20%. Well, as they go up and they get old, they go up sometimes 100%, 150. I've seen them as high as 300%. You know, above what they're supposed to be. So they're already bad and doing damage. Not because they're leaking DC, that's the second issue, but because their actual rated value of capacitance is no longer any good. The second thing that can happen to them is they can leak DC. They become a resistor. They change value, and that can do damage to the circuit. There are times when the capacitor will check within the 20%, still be good as far as the capacitance is concerned, but they've turned into a resistor and they're allowing DC through. Well, that destroys components. So they're still bad. They're bad for a different reason. So just because you can check one and the capacitance is within reason doesn't mean anything. You have to check it for leakage too. The third thing that can happen to them is they can become shorted, a dead short, zero resistance across. All of the power goes through. Very bad situation. And related to that, instead of going short, they could go open, like you cut the line, click, and there's no connection at all. Not at all. AC and DC can't get through. It's just gone. Just like you cut the wire, cut it right out of the circuit. So those are the things that go wrong with these. The most common issue is one, they're out of value. Two, they're leaking DC and they're doing damage. As far as being open or shorted, that's rare. They're usually okay, but the radio may even play, but they're doing damage. So you don't want them. And they're not expensive, so you change them. Okay, so they gotta go. Another issue is these blocks. Philco uses these blocks. And I'm going to try to turn this a little bit so you can see it. We'll show it again later. I might have to tilt it up a little. These blocks are Bakelite blocks. They're plastic Bakelite boxes. And in them they have capacitors that go from one to the other for these. Those capacitors go bad in this box. They actually just deteriorate away and they change in value really bad. They have to be replaced. That's a little bit tricky. You have to take the block out. You have to scrape out all of the guts out of the inside of the box, all of the chemical electrolyte in there, and to get to the capacitors. Then you got to unsolder them and take them out and put in new ones and solder them and put them in. And that replaces the original to make them look, if you wanted to, you don't need to, I don't usually, but you can refill them with some other solid material that's the same color. But nobody can see them, they're under the chassis, so there's no sense in spending that time and effort. But they do need to be replaced, cleaned out and replaced. Okay, what else can I tell you? These are the adjustments for the coils. And here for the oscillator antennas, coils, you got another adjustment here. Actually, no, I take that back. This is a resistor, candle resistor. It's a power resistor with multiple connections throughout the coil to one long coil with connections on it. So you have different resistor values based on where you connect. That's probably fine. The resistors in here are probably fine, with the exception of that guy. And, you know, they're probably fine. The tubes are probably okay. We'll go ahead and check all the tubes. But the critical things that I got to check before I even start doing a lot of work on it, or before I can even add power, is the transformer number one. That's critical. We need to know if the transformer is good. Each of these coils, we need to know if they're good. The IF cans, this joker have IF cans? Yeah, up here. This can and this can, these have got 2 coils in each one. We need to check them, make sure they're working. Because those are the parts that are either irreplaceable or very hard to replace, and they affect the cost of redoing the set, obviously. Normally they're fine, and my rates, of course, are on my website, but if they're bad, the only impact would be the cost of replacing it, getting another unit and replacing it. That would be if we could find them. So let's start by checking some coils. And again, I'm going to put this on continuity. Basically, we just want to know that the coils are good. We don't really need to worry about the value per se. I'll glance up there and check them out. Right, hold on, I'm not getting it. There we go. Okay, so let's check this resistor while we got him out of the circuit pretty much. I don't know what he's connected to, but let's find out what we got. I don't know if that's on that right. I should have did that first. Right. Okay, we got 9K, and that's what it is. We got 9.87K. I'm trying to get this where you can see it a little better. Glare is always a problem. There we go, 9.933, 9.9K. So 10K, right? And it's supposed to be 9.9K. So we're almost 1K up. 10K, 20% would be 2K, 9K, 1% is fine. So actually this resistor is testing fine. However, we don't know if it's going to drift when it has 350 volts across it, because it got really hot. So I'll probably replace it anyway, just because it's, old and could go out at any time. You can see how burnt it got. So anyway, that's that. Now we'll check. Okay, this is the line coming in here, and it's going to this capacitor because they're using it for the capacitor, but it also comes out here. So this goes to the switch, and this goes into the transformer, these 2 leads. So these are the 2 leads we want to check. We're going to check the switch at the same time. Well, that's a 3-way switch. Okay, so we're going to go from, actually we can do it, well, I don't know if that line cord's any good. We may get a false reading just because the line cord might be bad. There's another critter in there. All right, so we'll come across here. And we got nothing there. All right, we got something there. We got 12 ohms. And let's see if this line cord is shorted. I don't think it is, or I probably already have a reading. It's got so many bad spots, it probably is totally shorted. I'm going to just go ahead and cut it out so it doesn't give us bad reasons. No, it's not shorted yet, amazingly. That's a piece of wire, just probably an antenna wire there. Well, that cord ain't as bad as I thought it was. I was looking at this because it was wrapped around it. Okay, throw that over there. Okay. Actually, no, the cord's okay. It has been replaced at some point, I think. That doesn't look like, that's not original. Probably replaced. Let's see, and they got some tubing over it here. Looks like they might have connected it there. I don't know. Maybe not. Yeah. Strange. Anyway, so the cord is measuring nothing. I turn it on, and the cord is measuring 12.4 ohms. So we've just checked the line cord, and we checked, which means I can plug it in directly with my favorite suicide connection. We just checked the primary of the transformer, no problem there. So now we want to check the secondary of the transformer. Unfortunately, on this one it's a little difficult because the rectifier tube is on top of the transformer itself. So before we do that, and while we're on the bottom, let's go ahead and do our continuity checking on these coils. Okay, so we try this one here. That goes into there. That one's good. Try this one. I'm just gonna try to get a connection on it there. One goes here. Let's see if we can get it. That one's good. That's good. I'm gonna try this one. This looks like just a piece of rubber, yeah, so that goes here. Or maybe not. There. That one's good. And this one has, it has a couple wires on it, so this one has two coils. This one has two coils too. Let's try to see if we can find out where they go. That one goes there. And this one here, is that a piece of wire? No, it's another here. Okay. That one, oh, right there. No. Let's see where that one goes. I think it goes in there. I'm seeing something. Yeah. There it is. That's good. And this was the other one that had two, which would be what we did. We did from here to here, right? Yeah. So this one would be this one. And that may be just a center tap. No? And it's another coil. Where's the wire come out? Right there. That's good. Okay, so we verified that those coils are good. We verified the input of the transformer is good. Now we will check the IF coils. More slack. Cables are not wanting to cooperate. There we go. And we'll just start with any one of them that comes out. Okay, this one goes here. And there's that side. Yeah, okay. And then that's that one and that one. And where's the wire? Well, maybe it uses the can on that one. That would be strange. Oh, yeah, it does. It uses the can. Normally they have 4 wires. Okay, this guy's going to be a little hard to get to, too. I've got some wires coming up here. Let's see where they're going. Where are you going? Yeah. Yeah, that is it. Going here. Oh, that's going all the way over to there. I might not be able to do that one until I get these capacitors out of the way. I can't see where they're going. That's one. And I think this is the other one. No? Oh, it's coming up. Probably one of these. Oh. I don't know. It's hiding. Looks like it's going that way. Ah. Okay, which one are you? So that green is not going into that can? No, it's not. This one is. What's going in? Why is it coming out? It's stubborn. It's stubborn. What goes there? This one comes. Where you go? That's this one. Let's try that. Yeah, okay. Just didn't make good contact. Alright, that's that one. And then there should be another wire coming out there. And where are you going? Oh, this one has 4 wires, so normal. This green one is going to that tube, which is jumping over to here. And going, oh, it's a grid cap. Okay. Oh, that cap came off of that tube, and that's not a big deal. So one of the tubes in that can is missing its cap, I guess. Right, that's the green one, and then the other one is this brown one. Which also feels like it's going that way. Now maybe going here. No, it's going somewhere around here. There it is. So both of these cans, the coils, the IF coils are working. So good. The only other coils we need to check are the output of these, of this transformer. Okay, we're going to have a filament. Let me look at the schematic and see what we got. We have a 0.1 ohm from block to ground, which is probably the 6K. Yeah, that's probably the 6-volt filament. That would be the 6-volt filament. So if I go across, this one's missing its tube. Let's try it. If I can get in there. And that would probably be 2 and 7. Okay. Seems like the filament string is good. Now I could have just checked across the tube, because I do have tubes still in. And then the only way to be sure would be to take those tubes out. I'm just going to assume that the filament string is good because everything else is fine. We'll go ahead and check the rectifier filament, and because that one is kind of critical. The other one I'm sure is fine, and if not, I'll figure out how to get it to work. Anyway, Alright, on this tube socket rectifier, which is a 5Y4, filament on that is 8 and 7. I was pretty close to thinking that's what it was, but I wasn't sure. So we need 2 pieces of wire to get it in. Let's see, I can just use these. I'm not looking like that's right. 1. 8 and 7 should be the filament voltage. Oh, that may not be good. Maybe taking this transformer apart and figure out what's wrong there. Wait a second. Ah, there it is. Duh. Forgot, I'm looking at the top of the socket. I'm used to looking at the bottom of the socket. It's just the opposite. Okay, it's fine. So the transformer is fine. So now we know that we can replace these capacitors, these 2 and these 2 or 3, whatever is connected there. And we can actually fire this unit up. Let's go ahead and put the tubes back in it. Incredible packing job. Let's see if making some kind of noise in there, like we're in a case or something. Oh, it's in this can, okay. Good, we got the shields too. That's the 6F6 output tube. The joker goes right there. It's strange that that would have a can on it, doesn't need a can. Alright, and let's see what this one is. This looks like the rectifier, it is. He goes there. This should be 67. Yep. Q7. Is that right? Yeah. Okay. And he's the one that's missing the cap. And another radio I just did my initial on had two broken tubes. One of them was a broken cap. So there's the cap. It's in the, let's take it out of here. It's in this connector, and then it's stuck in there, and that's why it broke off when they took the tube out. Not a big deal. Okay, and that's the cap for it, which we'll glue back on. You can see all the glue in there is just dried up, so I just let go. That goes on there like that, like so. If I can save it, we'll save it. If not, it's not a big deal. We'll just get another tube, but I think I can save it. I'd like to save it. That's a nice original Philco. So what I'll do is just set the cap in the case, and we'll deal with that when we get ready to power it up. Right now I'm just going to put the tube in there. And that can that was in here, this can here, that's for that tube. No, I don't need to push that on there yet, but that's where that goes. Okay, so we'll set this aside. So we'll have it to send it back. Okay, so we know everything's okay with the coils and everything in that area. So we can go ahead and work on replacing these capacitors. Now this one, I need to find out. Okay, it looks like the can is ground. Oh man, it looks like that might be joined together. There's two in there, and it looks like they may be connected together. Excuse me. Oh yeah, it looks like what they did is these are 2/8. Why is one blue? Looks like these are 2/8 together in series. I mean in parallel, which would make it a 16. Unless that's not connected there. This one's a good one for playing around. And let's see if those tabs are soldered together or not. No, they're not soldered together. They sure look like they were bent together though. Okay, but I'm going to go by the schematic, not the way these are soldered. Now these are soldered together. Well, that's weird. Maybe no, that wouldn't be it. These cans are grounded because here's the ground wire. They're isolated, I mean, from the chassis. But here's the ground wire from the can. This one, on the other hand, is directly connected to the chassis. It's grounded directly to the chassis. So this has, this one has that on it. And this one's connected directly to the chassis. See, this one has insulated cardboard around it. And it has a tab. This one doesn't have cardboard around it. It's just connected directly to the chassis. However, it looks like they put those together in the factory. Why would they do that? Maybe that's a single can and this is a double can. I couldn't quite see that. Let's better look at it. Because two in parallel would double the capacitance value. More spiders. There's a whole family living in here. Okay, let's look at that can. Does it have the same part number? Yes, it does. So it is 2. It's the exact same Philco part number, which means, and that's the one I could read. Yeah, it has 2 in it. So this one has 2 in it too. Yep. Yeah, I see them now. A blue and a plaid. And the same thing here, right? Blue, maybe that says plain, blue and plain. Yeah, okay, blue and plain, that means the color that they painted the thing. So this is 8 from here to the tab, and this is 8 from here to the tab. Now these two, that does look like it has solder on it. They may have been connected together too. And these two are definitely connected together. So this is 16. And if those were together, that would be 16 and not 8. So time for me to check out the schematic. Okay, the next thing is to check the tubes. So I got to repair this one, which is the 6Q7. It needs to be repaired. I got to put the cap on him. But I'm going to go ahead and do that and check that one too. But I want to get ahead and get all the tubes out. Now I'm sure that getting this one out is going to be the same as that last one. The cap's not going to want to come off because it's been on there for so many years. So what I'm going to do is gently check it and see if it's tight. And then I'm going to spray some contact cleaner on it and see if that helps me get it out of there. They're old and they're being stubborn, and of course there's a can here, so that makes it difficult. Got it. These tubes, I don't think have ever come out of here. I apologize to the customer. If I'd have known that they were going to be so difficult to take out, I would have just told them leave them in. Normally they come out pretty easy. Mm-hmm. 6K7. Okay, and then we got this one, which is our 6F6 output tube. That's not original, obviously. It's a metal can RCA instead of a Philco. And here's another one with a cap on it. And it looks like it's going to be fine because it's a metal tube. And this is the 6A8 and our rectifier tube. So I'm going to go ahead and check these tubes, clean them up, clean up the chassis a little bit, and then put them back in, and then we will continue. The next thing we're going to do is, I don't want to put that there. I'm going to leave it there. The next thing we're going to do after I clean it is put some temporary electrolytics in here so that we can go ahead and power it up and see where it's at currently with new electrolytics. And then, because you can't power it up with these old ones, they'd definitely be a problem. They're bad, and it could hurt something seriously. So let me check these tubes, and then we'll continue.